Hey guys, this is your friendly neighborhood math teacher, Mr. Bennett. Today we're going to cover the 1.6 notes on two-way tables. So as you can see at the top, our learning target here is I can display data using two-way tables. So that's kind of our main topic today, as well as calculate what we call relative frequencies, which we'll get into towards the end. So first, what is a two-way table? It is a table that displays two categories of data collected from the same source. And so we're going to go through a couple of different examples here. But as you can see off to the right, it says the table to the right shows the results from a survey where students were asked if they play an instrument and if they play a sport. So that was really kind of the two categories, right? Whether or not they played a sport or whether or not they played an instrument. And so we can see at the top in our columns, we have plays a sport and does not play a sport. And in our rows, we have plays an instrument and does not play an instrument. So basically, did they answer yes or no to each question? So first, whenever you're working with a two-way table, one of the most beneficial things you can do is make sure that you have the totals for your rows and columns figured out. So in this case, to do that, to find the total number of people who played an instrument, I'm just going to add straight across my row here. So the number of people who played an instrument was 9 plus 14, which gives us 23. And the number of people who did not play an instrument gives us 33 plus 19, which would be 52. Okay, so the total is going all the way across. We have 23 who played an instrument, 52 who do not play an instrument. Now we can also do the same thing going vertically here. So in this case, we have those who played a sport. 9 plus 33 would give us 42. And those who did not play a sport, 14 plus 19 would give us 33. And if we've done this correctly, it won't matter at the end which direction we've added, but if I add 42 plus 33, or if I add 23 plus 52, each one of those should give me the grand total, which is 75. Okay, so this very bottom corner box here is always your overall total, which is an important piece of information that we typically will want to use here. So let's answer a few questions about this table and this information we've collected. So letter A says how many students play an instrument. So we're going to go to our plays an instrument row, look straight across to the total because it's just how many in general play an instrument regardless of sports, just focusing on that. So we can see we have an answer there of 23. Actually, let me write that in purple here to keep color coordinated. Question B says how many students play an instrument. So play an instrument and also play a sport. So in this case, we have this joint frequency here, this word and, which again means both are true. So plays an instrument, yes. Plays a sport, yes. That gives us a total of 9. Question C, how many students do not play a sport? So do not play a sport. Do not play a sport. Again, we're just wanting the total number of that, so we can go all the way down to the bottom and see that that's 33. So now you can see why our totals can become really useful here when answering some of these questions if we do that first thing. Did we have to? No, but again, it's just a nice strategy to use when working with two-way tables. Question D, how many students play a sport but do not play an instrument? So play a sport was green here, play a sport, but do not play an instrument. So now we have to go to our plays a sport column, but does not play an instrument. So as we can see, if we just kind of cross paths here, we end up in the box that gives us 33. And then lastly, question E, how many total students were surveyed? Again, we have that nice number down in the bottom right of 75. Easy enough. Now, question 2. If you think you can handle something like this on your own, feel free to pause it here and try it on your own. If you look at this and you're like, oh my goodness, I don't know what to do from here, feel free to just keep watching. But if you want to pause it and try it on your own, then come back and see if you got it right, feel free to go ahead and try. But question 2 says, Sydney randomly surveyed students at her school and found that 72 students ride the school bus. And 37 of those students buy lunch from the cafeteria. So kind of right there, right off the bat, we have some important pieces of information. So first one here is that 72 students ride the school bus. Okay, that right there. So 72 students ride the school bus. If I look down at my two-way table, I see this title here, rides the bus. And this, to me, right, looks like a total. There are 72 total students who ride the school bus. So that means I'm going to jump all the way down in this column here to my total and put in 72. Now the next piece of information here says 37 of those students, right, referring to bus riders, those students being the bus riders that they just talked about, buy lunch from the cafeteria. So in that same column, right, rides the bus, 37 of those kids buy lunch from the cafeteria. So now we need to find our buys lunch from the cafeteria, rides the bus. We can see those meet in that middle circle, or well, kind of top left box here. And so that'll be our 37. Those are the students who ride the bus and also buy lunch from the cafeteria. Our next sentence says there are 19 students that do not ride the bus, but they buy lunch from the cafeteria. So that's an important piece of this because it is connected here. So it says there are 19 students that do not ride the bus, so they are going to fall in the do not ride the bus column, but they also, those 19, do buy lunch from the cafeteria. So in this case, we have these two, which meet up in that kind of middle top column, or top middle box there. So that'll be our 19. It then gives us that 9 students do not ride the bus or buy lunch from the cafeteria. So in this case, those students do not ride the bus and they do not buy lunch from the cafeteria. Okay, that not here applies to both in this case. So again, see where those two meet. In that case, we have our kind of very middle center box here, and those are 9 students. So right off the bat, it gives us that information. And as you can notice, we're still missing some information, but now we can play kind of a fun little number game here. And so now we want to figure out what our totals are, right? We talked about how important finding totals can be. So first of all, we can add straight across to get those who are buying lunch from the cafeteria. So 37 plus 19 gives us 56. We can also figure out the number of students that do not ride the bus. 19 plus 9 gives us 28. We can do a little backwards mapping here and question ourselves and say 37 plus what would give me 72? And so another way of thinking about that would be 72 minus that first 37, which if we do that, we get 35. Now we can add up across the row here. 35 plus 9 gives us 44. And at the very end, we can either add straight down or add straight across the bottom. Either way, if you did it correctly, you should get the same answer, which in this case is 100. So to now go through these couple of questions here. Question A, how many students buy their lunch? So buys lunch. Our total is 56. Question B, how many students ride the bus but do not buy their lunch? So ride the bus but do not buy lunch. Those meet right here at 35. Question C, how many students do not ride the bus? So that's just looking for a total here, which would be 28. Question D, how many do not buy their lunch? So do not buying their lunch. Again, we want a total, which is 44. And question E, how many total students were surveyed? We found that to be 100. Okay, so hopefully you're kind of getting the hang of how these work and kind of how these function and the important pieces of information we can take from them. I would really suggest right now that you try to kind of fill this one out on your own. Don't worry about this part that says relative frequency. We'll get to that in a second. But at this point, I would highly recommend you try pausing the video, read through that problem, see if you can fill out this table right here on your own. And then again, kind of quickly skip forward. I'm going to kind of go through this next part fairly quickly. But skip forward, see if you got the correct answers. If not, maybe go back and watch the video, but hopefully by now you kind of get the hang of how this works. So if you want to pause the video, go ahead and pause. I'll wait a couple seconds, then get going. So this one, it says, Adam surveyed 120 random students, which is why we have this total of 120, and asked them if they plan to attend the school musical. Right, so we have our questions about the musical, and then we have our grade levels down here on the side. Right, what's your grade? Of the 80 students who responded, so we have 80 students who responded that they are attending the musical, hence going to the musical, there's our total. It says 15 are, oh, that did not want to adjust there. There we go. 15 are 7th graders. So of those 80, it says 15 are in 7th grade. So that's where that number's coming from. Of the 40 6th grade students surveyed, so again, we've got 40 6th grade total. There's our 40. It says 13 of them said they do not plan on going. So of those 40, 13 are not going to the musical. And only 10 8th graders surveyed do not plan on attending the musical. So we know that there are 10 kids that are in 8th grade who are not going to the musical. So if we fill this out, we can kind of backwards map through some of this. It gives us just enough information. So kind of the first one I would look at here is, I would say, how many 6th graders are going to the musical? So in this case, we know there's a total of 40 6th graders. Since there's 13 that are not, what number plus 13 gives me 40? And so again, another way we can kind of work through this and backwards map it is to think, well, I have the total of 40 minus the 13 who are not going, and that leaves us with 27. Now we have enough information to fill out this column. So we know 27 plus 15 plus some other number gives us 80. So 27 plus 15 is 42. And so 42 plus what gives me 80? So again, another way we could kind of think of this is 80 minus 42, which gives us 38. Now we have enough information to work our way across 8th grade. So 38 going plus 10 not going gives us a total of 48 8th graders. Now we have enough information to figure out how many total 7th graders there are. So we have 40 plus question mark plus 48 gives us 120. So again, if we add the 6th and 8th grade together, that gives us a total of 88. And so our question mark here, our 7th graders, becomes 120, our total, minus 88 from the other two classes, which gives us a total of 32. Now we can again kind of now backwards map through 7th grade. So 15 plus what gives us 32. And in that case, this would be 17. Right, or 32 minus 15 gives us 17. And then now we can just add all the way straight down, those not going to the musical, add those all up. 13 plus 17 plus 10 gives us 40, which if we double check, 80 plus 40 does give us 120. Cool. So all of that checks out. Now, all of that is going to help us solve this next part, which our next kind of key vocabulary word here is this relative frequency. So you need to know this term, be familiar with this term here, relative frequency. So remember, frequency by itself just means how many times something happens. Relative frequency means how many times did it happen relative to something else. There's a comparison here. And so that comparison is looking at the values in each category divided by the total number of values. And so we're looking at more so the percentage that it's going to occur. Okay, now we can write these as fractions or decimals, and in this case, we will actually leave it as all three of them, and we'll talk about them in different ways. But they're all referencing the same thing. So for an example, question 3 says, find the relative frequency, so I'm going to zoom out here, using the data from the two-way table above, so the one you just did with the musical and the different grade levels. Round to the nearest hundredth, so nearest hundredth, if necessary. Now something to kind of quickly review when it comes to decimal places, our 10th place is 1 decimal. Our 100th place is 2 decimals. And our 1000th place is 3 decimals. Okay, so in this case, it asks us for the 100th, which is 2 decimals. Okay, a lot of the times in our class, if we're using decimals, we will use the 10th. Okay, that one's pretty common for us. But in this particular case, because we're going to be dealing with percentages, it's helpful to use 2 decimals. So for example here, if I zoom out again, our relative frequency for the 6th graders that are going to the musical is 27 6th graders. So the frequency was 27, but the relative frequency is 27 out of how many total students did we have? Well, if I scroll back up, we had 120 total students. So 27 out of 120, you can do that on a calculator. And if we round that, we get 0.23. And the reason, again, why we want two decimal places is because that then tells us that this is 23%. That 23% of our students were sixth graders that are going to the musical. And so if we fill this out in a similar way, we now have 15 seventh graders going to the musical. So that's 15 out of 120, which is 0.13 or 13%. And again, I would highly recommend always writing all three. So start with the fraction. That's where our numbers came from, right? There were 27 out of 120 students, which in turn gives us the decimal 0.23, which we can convert to the percentage. And remember, if you're not sure how to find the percentage, you just take the decimal 0.23 and you multiply it by 100, which moves the decimal place over to 23. Okay, so I'm going to kind of now quickly go through the rest of this. Now that you kind of see where these numbers are coming from, I'm just using the table up above. But to keep this video from being 7 hours long, I'm going to go ahead and kind of quickly speed run through this. So 8th graders going to the musical was 38 out of 120, which is 0.32 or 32%. And the total number of kids going to the musical was 80 out of 120, which is 0.67 or 67%. Not going to the musical, starting up at the top at 6th grade, we had 13 out of 120, which is 0.11 or 11%. 7th graders not going was 17 out of 120, which is 0.14 or 14%. 8th graders not going was 10 out of 120, or 0.08. So the total number of students not going was 40 out of 120, which is 0.33 or 33%. Oops, and I forgot. The 8th grade is 8%. So remember, if I ever have a 0, right, 0.08, if I move that decimal place, when I multiply it by 100, I now get 0.08%, but I don't need that leading zero. Like, you can just get rid of that and just write 8%. And then our last, and our totals here, this is the total number of 6th graders, was 40 out of 120, which was 0.33 or 33%. Our total 7th graders was 32 out of 120, which comes out to 0.27 or 27%. Our 8th graders was 48 out of 120, which was 0.40 or 40%. And then lastly, we have our total, which was 120 out of 120, which, hopefully you know, is 1.00, also known as 100% of our students. Okay, so again, if you do it right, our total should be 100% because that's how many kids we had, 100%. And if we add up our percentages across the bottom, 67 plus 33 gives us 100. 33 plus 27 plus 40 also gives us 100. And so now we can answer those couple questions down below. What percent of students surveyed were 8th graders? So 8th graders, my total percent was 40%. Question B, what percent of the 6th graders plan to attend the musical? So 6th graders who plan to attend, who are going, and it does ask what percent, is 23%. And what percent of the 7th graders do not plan to attend the musical? 14%. So again, a relative frequency table now allows us to talk about percentages. So it might be helpful to say, okay, yeah, there are 30 kids, or in this case, 27 kids not going, going to the musical, and 27 might seem like a lot, but it's only 23%, right? Not a huge percentage. Or, what does that mean if I say 80 kids are planning to go to the musical? Okay, great. That doesn't seem like too many kids, but 67 means it's 67%. That's more than half of the kids are going. That's useful information to know. So sometimes it's useful to just know how many, which is your frequency, just purely how many students. And sometimes it's helpful to know what percentage, which is your relative frequency. Okay, so just kind of depends on the situation and what it is we're looking for. And so that's all for 1.6. Hopefully that gives you guys a good head start on your practice. Make sure you guys are working on that. And if you have any questions, just let me know. Otherwise, hit the like button, smash the subscribe, all the random YouTube, blah, blah, blah. I don't know. I'm not looking for subscribers. I know I'm not going to get paid for this, but I hope you guys have a great rest of your day, and I will see you guys soon.